Hey, hi there, my name is Sam, and I'm going to do a quick run through of RStudio and some plotting in Ggplot for those of you who'd like to review the knowledge or to catch up. What you're looking at right now is the standard RStudio window that you will see when you open it up for the first time. RStudio is the development environment for R. You don't need to open R. You just need to have it installed on your computer for RStudio to work. What you see first of all is the console taking up the large part of the screen. The console tells you what scripts or what code you've been working on, and also shows any processes that you have been doing while the coding has been happening. It doesn't save, so anything that goes into this console will not be retrieved. It will be deleted when you quit RStudio. So just be aware that nothing can be saved here. What you can save is in a new script, and if you look at the top left here with this button with the green plus sign, you can do new file and new R script, and that opens up a new Word document like document where you can start to do your scripting and your coding so that you can actually have something that you save. In this window, everything can be saved as long as you save it onto your desktop, onto your local computer. On the right here, we have the working environment, or the global environment as it's called. This is where you can save for temporarily objects and parts of the data that you are working with. And on the bottom here, we have a series of tabs. The first is Files. It shows your working directory, and I'll explain what that means in just a second. You've got Plots. This is where your graphs and charts are going to be displayed. Packages, which is a list of expansion packs and add-ons for RStudio that help you do different things. And then also the help, where it shows the documentary for packages, and a couple of others tabs that we won't be using. So what I'm going to show you first is that here on the script, you can start to type whatever you want, and be aware that the data won't tell you whether it works or not. If you've been operating on it, it will either do a silent success or it will give you an error. So if, for example, I wanted to make a little object that was just called hello, I would type that, put a chevron here or a caret with a hyphen, which is like a little arrow indicator pointing at the name of the object that I'm creating, and I could create a simple vector. So I could do C, which is for vector, and I can do 1, 2, 3, and then 5, let's say. And the parentheses, the brackets, auto-populate on the right-hand side here. If I press Command Enter, then I get an object on the right here, which tells me that the object is called hello, as indeed we specified here. It's a numeric vector, NUM, and it has values going from 1. It has 4 values going from 1. Sorry, 5 values going from 1 through 4, and the values are listed here. If you want to delete any objects from your working environment, you can use this little brush here. The icon will delete everything in the working environment, but if you want to delete specific items, you can go to RM here in the script, and in the brackets you type in the item or the object that you want to delete. So if I press Command Enter now, you'll see it's been deleted again. So 2 options there: 1 to delete everything, and 2 here to delete specific items. So as you're working in R, of course, you can use Command and plus and minus to make the working environment larger and smaller. This is useful if you're spending a lot of time in front of it and you want to make it a bit more legible, especially as you go through many lines of code. The next thing that you would do when you start a project usually is to start with setting the working directory. Now I'm going to go here. There's 2 ways to do this. One is to go to Session here in the top and do Set Working Directory, and then choose Directory. And then now I'm going to specify the directory into which I have put my data. And so that's this for me. And so in here, in this directory called data, I have actually the data that we're going to use for this short workshop called lx.csv. And so in accessing that data, I would need to specify that I need to go into the folder called data and then access the data there. The little refresh button here, by the way, is useful if you've changed the directory or changed something in the directory, and you can get an updated view of what's inside. So let's get started with. Oh, and the other way to do it, is to do set WD, and then into this you specify a path. So for example, I could put here, I'll put an imaginary path, which would be something like the root, and then documents, and then data, and then data. So if data was the folder within which I had my data, then I could set this path as the way to set the working directory. But you don't need to if you've done it already using this. Now, I would also say that you don't need to do this if you're working with an R project. We're working with just a single script here, but you'll notice that here there's an option to create a new project, and I won't do it now, but if you create a new project, as we've spoken about before, what that does is it sets the working directory already to the folder in which your project is already set. And you can ask me more about that if you're not sure as we go along. So what we'll do next is we'll install some packages. Anything that I put here in the hash, in front of the hash sign, is just a comment and doesn't get worked on. So I'm going to go install.packages, and you can see that RStudio helpfully auto-suggests the function that I want to call, and so that's what I'm going to do here. And I'm going to put in quote marks ggplot2, and the quote marks indicate that it is something which is outside of the environment of RStudio, and by calling it, we're going to bring it into the working environment. So I'm going to press Command Enter, and it's installing. I believe it's installing. There we go. In the console here, it says downloaded binary packages are in, and then it specifies the directory or the path, and because there's no errors or warnings, it means everything worked fine. The next thing we do is we attach ggplot2 to our working environment. It's like we have the package already, we just need to activate it for this particular session. So I press Command Enter, and now we can check under the Packages tab that ggplot2 is indeed, it's here, it's listed, and the little tick mark suggests that, or it tells us that it's attached to a working environment, it's activated and ready to use. I'm also going to install Tidyverse, which is a package for managing data a little better. It asks if it wants to restart R, but I'm not going to because I don't think it's necessary for this particular example, although you're welcome to if you want. Let's see, Tidyverse. And we don't put quote marks in the second instance here because the object is now part of our working environment. Even though it's not listed here, my point is it's no longer alien to the working environment or to the session of RStudio, sorry. Okay, so the next thing we need to do is open a comma separated values file. And so this is a very common function that you will use. We do read.csv like that. And we are going to access, like I said earlier, we're going to access the file that's inside data here. So I'm going to put here data, and then sorry, it needs quote marks, data/lx.csv. And that should work. When we press Command Enter, you can see that when it reads the data, it puts in the console everything that it can see, and it managed to read everything we've got here. The data we're using is life expectancy data from 1933 to 2023 for men and women in the United States, or life expectancy at age 0, as they say in demography. Now, we have read the data using this function. Our data is in comma-separated value format, but we haven't actually incorporated it into our working environment, and so that's the next thing we need to do. Just like we did up here with hello in line 2, we're now going to find a name for our object, and I'm going to call it full_dataset, and give it the arrow, and then I'm going to repeat this function that we just did above, read.csv. You can copy and paste, of course. I'm going to type it out here, just I guess for good practice. CSV, and there we go. Now the difference is nothing is showing up in the console, but it is showing up in the working environment, and that's where we need it to be. You can see it's recognized its name, 91 observations of 3 variables, or another way of saying that is 91 rows and 3 columns. And when we click on it, a little tab comes up here, and we get a nice view of the data. We can't edit it. This particular view doesn't allow us to edit it. We can change the way we look at it, but ultimately this is just so we can see what's inside it. Also on the right here, if you press the little blue triangle, you can see how the variables list out. The $ indicates that we're looking at a variable within a data set, and this little graph logo also opens the tab in just the same way that I did. I'll just do it one more time. You can see it there. So that's nice, and that's a great way of, that's a nice little way to sort of preview the data. But if you want to preview the data in, I'll put here sample / preview the data. If you want to get a little, just a glimpse of the data, you can do head full data set like this and run that. And what in the console, what it does is it will show you just, in this case, the first 6 rows plus the headers here. And you can do the same again, tail, full data set. Notice that it also auto suggests the object as well as functions, so that's convenient for us. And now it's showing the last 6 rows of the data set. And then if you want to print the whole thing, just like you would do in Python, if you use Python, you do print. I think that's how it goes in Python. Print full data set, and there we go. And that's the whole thing. Be aware, of course, if it's a big data set, you might crash R, so use that with caution. But let's move on now to set up a plot using Ggplot 2. So let's set up a plot. The first thing we want is to do to set just the graph itself without any data on it. So I'm going to call the function Ggplot, not Ggplot 2. Ggplot 2 is the name of the package. Ggplot is the name of the function. So the first thing that goes inside these parentheses is full data set like that. That's the data object that we are calling, followed by a comma, and then we set up the aesthetic mappings, AES. And within that, I'm just going to set up one mapping, which is the x-axis, and along the x-axis, I want it to be the year. So when I press enter, when I press Command Enter on this, what we get in the plots is a very simple graph that really only shows data on the, well, not even data, it just shows the mapping of the x-axis. We get year as a nice label, and it's called, it's arbitrarily defined a series of tick marks that go from 1950 to 2025. So that's a great start. And next, we're going to add data points to the plot. And what we will do here is, first of all, we start with this. This is the point at which we start to layer our plots like a cake or something like that. We put a plus sign. This plus sign is unique to Ggplot. It's a little operator, I guess we could say, that we use to layer the different elements of the plot. So we'll go now to geom point. Now, when I type in geom, RStudio is suggesting many functions that belong to Ggplot 2, and you can see the number of different types of plots that are available through Ggplot 2. We've got bar chart, we've got a box plot, we've got curve, density plots, dot plots, hex histograms, geom line, obviously very important, geom map, and it goes all the way along. But what I'm going to do is we're going to do geom_point, and this is for a scatter plot. We also define the aesthetic mappings for just this line. And in this case, it's going to be y equals female, so that the data is the same for females and males when it comes to the year, because of the years are the same, obviously, for male and female, but the values of the life expectancy between males and females are different. So that's why, in this case, in this instance, the y value, we will define it here as female. And I'm going to put here, and I'll explain why I'm doing this in just a sec. The color is going to be female. And what this does is it defines a thematic mapping for the color. Instead of defining it arbitrarily, we're going to tell R that if the data belongs to the female variable, then we're going to set it to be a particular color for every single time that it's called. You can also define it arbitrarily, but I'm going to do it this way for this particular example, and I'll show you the difference in just one sec. So then once that's done, we also add here, we close the brackets for this particular data mapping, but then within the aesthetics section, we can put here size equals 1, and that is the size of the data points. So before I go any further, let's just see if that works, and indeed it does. So without saying specifically which color it's going to be yet, it's already chosen a sort of red for us, and the data has begun to be plotted. So we'll move on, put a plus sign again at the end of this line, and we'll go to geom. We'll go to geom point again with aesthetics, and now we are going to define y equals male. And again, I'm going to go to color equals male, because in a minute I'm going to define what those colors relating to the male and female data should be. Size equals 1 again. And now we'll have data on both data on both the variables. The size 1 here can be almost anything you want. If I put size 10, the data points go supermassive. And there's really no limit to how big the data points can be. Now it's just one big data point, so we'll just put it back to 1. And then we'll go to the next line, in which I'm going to add the labels for this particular chart. We'll put here title, so we're going to find the title, and I'm going to put here male and female life expectancy, US 1933 to 2020, 2024, 2023, 2023. We have an error. Object is missing with no default. Oh, the object is incorrectly defined. That's what it is. I've put here labels. What it actually needs to be is labs. There we go. So the function itself, I typed it out wrong, and that's why we got the error here, where error in labels. And basically, this is R's way of saying, I don't understand what function you've called. Okay, so that's good so far. That's looking good. Now, we'll add the color, as I said a minute ago that we would do. I'm going to put here, define the color for each variable. Now, at this stage, I'm just going to copy and paste, because we're building it up line by line. And we're going to put another plus sign here. I'm going to put a paragraph break, which doesn't. It's not a problem for for us to do that. And I'm going to put here a function is called scale color manual, and this is a function which defines the colors that relate to certain values. And I'm going to put here, so the values are going to be a vector, as we defined earlier with the hello object. If female is called, we're going to color it green. And helpfully, the green shows up as the color it's going to be. That's a nice preview there. Comma, and then I'm going to do the same for male again. And we'll put, let's say, navy. Okay, so with any luck, if I press enter now, the colors are specified, and each time the variable is called, it will refer to the color that we've defined in this. And this is useful because rather than defining the color for every single line, we're telling R that we want the color to relate to whatever we've told female data should be colored. And this will be useful when we go to doing line plots as well in just a second. And I believe we'll do that next, actually. So we will now add another plus line here. I'm going to add a break. And we're going to add lines, and we're going to add a function now called geom line. I think I might have pointed this out just a second ago. Define the aesthetics as we did before. I'll put here y equals female. This is a repeat. This is a repeat of what we just did, except this time it's going to be for a line rather than a scatter plot. Color equals female, and now the the way we define the size of this particular line is not using the size argument, it's using the line width. And we can define that at about 0.5. Of course, you can edit that all you want. And we also define the alpha, which is the transparency. So let's see how that looks. Unexpected symbol. Oh, I think we need a comma here. Is that right? There we go. Okay, so we've begun. We can start to see now, if I move this across, that we've got a semi-transparent straight line go through all the data points, and that's quite convenient because it connects the data points we've got here. So that's nice. And then we'll do the same again for male data. So we've got geom line, aesthetics, y equals female color. Sorry. I'm copying from above, but I need to also go color equals male. There we go. Add the change. Close the brackets, and then I'll do the same line width. Line width equals 0.5, and alpha equals 0.5. You can change these as much as you like, but that's what I'm going to put for this. And now for both of them, we have a lovely series of data points that are connected by lines to make the far ends of the data much clearer for us to understand. Particularly here, it gets kind of, I would say noisy, but that's probably not the best word to use, but that's what we have. Okay, so the plot itself is looking pretty good, but we want to make these tick marks, the divisions of the data points on the axes, look a bit more specific, right? So that we can actually get a sense of, to be able to read the data points more easily. So we're going to add finer breaks on the axes. And so what we do, I'm going to copy and paste once again. Add another plus sign. And then what we've got here is a new function called scale y. I'll start with x. Scale x continuous. And we will add breaks. And it'll be a sequence that goes from 1930. That's the minimum. That actually is 3 years before the data starts, but it's a nice round number to start with. And then ending in 2023 when the data ends, and we'll go in breaks of 10. So let's see if that works. Here we go. So it's all clustered now. It's all kind of crushed up. But once you move the plot over like this, you can see we've got much more finer gradations on the tick marks, which is really nice. And so I'm going to do the same again for the y data. We'll go scale underscore y continuous breaks. Breaks equals, we'll do a sequence. In this case, the data is going at the y-axis, so we will do a life expectancy of 50 right through to 100. I'll do increments of 2, and so let's see how that looks. So that's plot looking a lot nicer now. Going from 58, let's say, even though we defined 50 as the minimum, it starts the tick marks where the data begins at 58. So that's nice. It's not, it's sort of automatically added the lower bounds within a realistic limit for us there. So that's good. Then now what we can do is add a subtitle and a shaded area with a caption. So let's take this, add a new line, and this line is going to be called annotate, and the annotation is going to be for a rectangle, rect, and the way we're going to define this is almost like if you imagine like a Roomba or a bird that was flying in a shape. We go from one coordinate to the next, going in, I think it's a clockwise direction. Let me see, x min, x max. In this sense, we're actually, well, the order doesn't matter so much, but I think we're actually going, well, we're not exactly going in a path, but we're defining each point as we go along, because that's the right way to put it. We can order it in whichever order we like. But I'll put here, I'll show you what I mean. X minimum, the minimum X value is going to be 2019. The X max value is going to be 2023. The Y min value is going to be minus infinity. And the Y max is going to be infinity. Now what I've done here is defined a box where it's going to shade the COVID era in the early 2020s, but it's also going to shade the full length of the y-axis just to make it clear that we're covering any data that might fall in that period. So let's see how that looks now. There we go. Now it's totally, what would you say? It's totally opaque. So we're going to add a little value here, which is going to be alpha. Alpha equals 0.2. Oops. Fill equals gray. Let's just put gray. You can, that gray is actually too light. So we can either make the gray darker with like, we could change the gray, or we can also change the alpha back up to something like 6. And there we go. I'll put, let's say 5. There we go. So that's a good way to draw attention to a particular data period, and then you can define how stark you want that shape to be. Now I also said we were going to add a subtitle and a caption. And so we're going to go back up to labs here, labels. And so I'm going to put here, I'm going to say that the subtitle is going to be, start new line. It's a little easier, isn't it? The subtitle is going to be data retrieved from the human mortality database, and then a comma, and I'm also going to add the caption. Caption equals shaded area shows the COVID-19 doesn't need caps, does it? COVID-19 pandemic period. And then we'll close that up. With any luck, here we go. So now we have a table with a title, a subtitle, and a caption, and a box that shows the area. So that, I think, is where I'm going to leave it now for this explanation. If you want more details about how to adjust the text in the plot or use a custom font, then I'm happy to provide that. You probably already have it in the script I've sent you, and you can go from there and you can create plots that are much more compelling, visually interesting, and also, most importantly, when it comes to R, replicable. So you can repeat this with different data sets but the same format. Then now you have this and you can run it as much as you like with different data sets. All right, I'll leave it there. Thanks.